All right, cool. So now let's do this one. So just as a reminder, we're on homework 9, recommended problems. Yeah. All right, the height of a right circular cylinder is twice the radius. Okay, whew, before we even get on the second one, let's just think about that first sentence and draw it. So the height of let's draw a right circular cylinder. Okay, so here's a circular cylinder. Booyah. That's not the best, but you guys get what I'm trying to draw. So the point of it being right just means it doesn't look like this. That's all it means. It's not something weird and slanted. It's like straight up. And then I'm going to draw like so we can kind of see through the cylinder. Cool. So let's draw the height now. The height of it would be from here to here. Cool. And we know it's twice the radius. So let's say the radius of this circle is r. Well, then the height is going to be twice that. It's going to be 2r. So now, and this is kind of a weird one. I want to express the radius as a function of the volume. I know most of us are very used to writing the volume as a function of the radius, but we've got to do it a little different this time. But you know what? Just because we're more familiar with the equation for volume, let's go ahead and write that. So the equation for volume is, well, the volume of a cylinder is basically like a bunch of circles stacked on top of each other. So it's the area of the bottom circle, pi r squared, times the height, because that's how many circles we're stacking on top of each other. So that's, or if you ever forget, you can just look it up. So that's the volume for the or equation for the volume of a cylinder. And okay, so okay, let's just rewrite h since we already know h is 2r, right? I could just write this as v is equal to pi r squared times 2r because it tells me right from the beginning it's the height, which I could write 2 pi r cubed. I'm just moving stuff around and simplifying it a little bit. Okay, so now we know the volume is equal to 2 pi r cubed, but is that what I'm looking for? No, I'm not. I'm looking for the radius as a function of the volume. Right now, I have the volume as the function of a radius. So what that basically means is that I want to get r is equal to something. In other words, I want to get r all by itself. So let's just solve for r. Is r by itself yet? Nope. So the first thing I'm going to do is I'm going to divide by 2 pi. I'm going to write it up here so that I get v over 2 pi is equal to r cubed, right? Because that cancels out. All right, now how do I get r cubed all by itself? Well, the opposite of squared is the square root, so the opposite of r cubed is the cubed root. So let's do the cubed root of this, and I'll get r is equal, or I'll get the cubed root of v over 2 pi is equal to r. And so I'm going to write it down here again, but starting with r. R is equal to the cubed root of v over 2 pi. So now I have the radius as a function of the volume, right? Because the only variable I have here is v, so it's a function of the volume. Remember, pi is not a variable because it can never change. It's just a number. All right, cool. Let's double check my answer. Oh, that's from last time. Yeah, buddy, I'm right. All right, sick. So there you go. Nice job.